Okay, so slope is rise over run, and for f, it goes down 1, so that's -1 divided by +1, so my slope is -1 times x, or just -x. And my y-intercept, this piece of the line doesn't intersect the y-axis, but if I were to continue my function backwards, keeping the same slope, it would have intersected at +7, so it's -x plus 7. And then we can do the same thing for g of x. My slope, it goes up 1 and over 2, so my slope is +1/2 times x. And my y-intercept, if I had continued the same pattern backwards, would have been -1. So 1/2 x minus 1. Okay, and then we can graph those in our calculator. I don't have my calculator with me, but you can just enter in f of x as f1 of x and g of x as f2 of x. But after you write in the equation, there's a little gray button that has a straight vertical line on it, and that that restricts the domain of that function. So if you push that button, it's pretty close to the blue control button, and then you just type in the domain afterwards. So the domain of f, remember, is under number 1, and so it's 1 is less than or equal to x less than or equal to 5. So we would put in that little vertical line and then just type in the domain just like that. To get the less than or equal to, if you press Control and then the less than button, will give you that less than or equal to. And we can do the same thing for g. That little vertical line, that's a -1, and then put in the domain for g of x, which is 2 is less than or equal to x less than or equal to 8. And then when you graph those two lines, you should have what the original graph was over here, what was given, those f of x and g of x. It should look the same. And then we can enter in for f3 of x, we can enter in f1 evaluated at f2 of x to get our composite function. Okay, and that should give you the exact same line that we have here with the same domain and everything. It's not super important if you couldn't get this to graph. There will be very little times where you're actually asked to do this. It's just to help show that this really is what happens when we compose functions. Okay, and so then algebraically, we can take our f of x and our g of x and come up with the equation by algebra. Sorry, I'm erasing some stuff. So I just rewrote my f of x and g of x because what we're going to do, we're going to evaluate f at g of x. And what that means is to take your g of x function and to plug it in for x into f of x. So every time there's an x in my f of x equation, I plug in what the g of x equation is. So then now my f composed with g, which is the same thing as f evaluated at g of x, is going to become negative. I have to plug in my g of x equation for x, -1/2 x minus 1, and then I still have to add that 7. So now I'm using what g of x was instead of x. And then we just simplify algebraically. This negative is the same thing as multiplying by -1, so I need to multiply everything in the parentheses by -1. So that +1/2 becomes -1/2, and I have to multiply -1 times this -1, so it becomes +1 plus 7. So then that all becomes -1/2 x plus 8. And we can look and see that our graph does have a slope of -1/2 because it goes down 1 and over 2. And if we did continue it backwards, it would cross the or the y-axis, excuse me, at +8.